Okay, this is the errors test. Going through the errors test which you did when I wasn't here last week. We'll go through them bit by bit. First one was a 21 mark question, lots of marks. So, part A, first off, there's a mark for a null hypothesis, if I can focus that in a bit better. A mark for a null hypothesis mu was equal to 20. Let's get that back on there. There was then another mark for an alternative hypothesis. Mu was not equal to 20. We were doing a test at a 5% significance level. Stating the distribution. Now, if that's implied somewhere else in the question, you can have it, but I really do recommend that you do state the distributions you're using in each question. So I gave a mark for that. Here's the probability calculation. The x minus mu over sigma squared over n all square rooted. So a method mark for the calculation and a mark for getting out that value of minus 1.5. Then there are two ways you could go from here. What's the easy way going from here? Remember, this is a two-tail 5% test. What's the easiest way to come to a conclusion from here? Yeah, use the bottom of the table, the tails. So what number would you be comparing to for a two-tail 5% test?
1.96.
Yes, 1.96. That should just be sort of in your head, really. So yeah, I've said down here at the bottom of the screen, as z is minus 1.5 is not, basically it's not more extreme than that minus 1.96. It's not significant. So I'm accepting h0 for 1 mark, which means mu is 20 for a mark. If you've done it the other way, you can claim that mark there if you haven't got that probability for this sentence down here. But basically there should be 8 marks altogether. So there's 1 mark off the top of the screen for stating the null hypothesis, 8 marks altogether for that part A of the question. Any questions before we move on? Okay, part B said the manufacturer decides to take a sample of 25 tubes from each batch produced in order to monitor the process. Using a 5% level, find the critical values of X bar that would determine whether he rejects the batch. Assume a two-tailed test. So, here we go. It's what you can see on the screen there for 5 marks. You need to find the critical value, same sort of calculation as before, c over sigma squared minus n all square rooted. Set it equal to minus 1.96, set it equal to plus 1.96, rearrange the equation, find your c values. That should be a nice easy 5 marks really if you got part A. There shouldn't really be much problem there with part B. Any questions, any queries about that part B before we move on? Okay, part C. Suppose the average length of a tube has increased to 21 centimetres. This is like the great god of statistics has come up with that number. That's where it's come from. We don't argue with it. We just know we need it for the question. What is the probability the manufacturer would accept the batch, believing the mean to be 20? How could that question have been rewritten in terms of errors? What's the probability of a type 2 error? Yes, if I get my other bit of paper, okay. So this question is linked in with errors. Here's the solution. They're saying, what's the probability to accept h0 given mu is 21? Well, you accept h0 when x bar is between these two critical values here. And we said it's given that mu is 21. So there's a mark for basically working out that logic. Working out the probability x is less than that one, working out the probability it's less than that one. Go through the calculations. This one here had a very, very extreme value. It's outside of your table, so you assume that probability is 0. And there were the 8 marks. Any questions, any queries? Closing that video clip.